We're going to take a look at disk storage, and in disk storage we're going to be just going over things really quickly. So let's look at database files. They're stored physically as files, records. Storage can be in a disk. So we're going to look at how to organize file storage and how to access files efficiently. So first we have physical storage. It's primary storage and storage media accessed by our CPU directly. Then there's secondary storage, which is where data is copied into the primary storage. Then data can be processed by the CPU. So we can have like hard drives or something like that. This is large capacity, like we can have multiple terabyte hard drives, and low cost, which is nice. Database storage. Data stored on disk is organized as files or records. A record is a collection of data values about entities and relationships. Records should be located efficiently. Now we have primary file organization. Now, how to place files of records on the disk physically. We're going to look at how to access records. We could use a heap file, so this is unordered files. Sorted file, hashed file, and a binary tree. These are all ways we can look through our file organization. And we have second organization, which is where we use alternate methods, so other than the fields of primary organization, to locate our records. These are just anything that's like other than the ones that are listed in the primary. So look at disk device. It's single-sided or double-sided. We have disk packs, tracks, and this is represented by a cylinder, tracks with the same diameter. So this is going to look like a hard drive. We have these tracks in here, and we have a read and write head, and it's going to write on these disks. So that's how that would work. Let's look at our disk block. The division of a track into equal size disk blocks or pages, it's set up by our OS when we do disk formatting. So when we format a disk, when we install like a hard drive or an SSD, we have a block size. Blocks are units transferred between disks and main memory for processing. Now we have our disk read and write. So that's just talking about how we read and write it, and then the time it takes to read and write it. So the time is equal to the seek time, which is the time it takes to look for it. We have the rotational delay, so latency, for when we're reading and writing. And then we have the transfer time. It's more efficient to transfer n consecutive blocks on the same track or cylinder, and then locate data on disk, which is a big bottleneck because it has to go through the entire disk storage and look for what we want to specifically find. We have records, so we can look at a record that holds our certain kind of entities or files. We have fixed length records, and with fixed length records, it records the file to the exact size. So we don't want to have anything smaller or larger, we want to have the exact size. The downside is if we make it too big, we waste space, and if it's too small, we might not fit everything. We have variable length records, which is kind of like the same. However, it is of variable length, and we can have things of larger or smaller lengths, and we won't be wasting space if it is too small. We have record blocking, so an allocated amount is reserved for disks. We have one record, many records, and then this is just showing that if we have 20 something, if we have a size, and this is showing that if we have something of size 20, we can store it 3 times, and we have this leftover space of 10, and how to calculate it with our blocking factor and our unused space. We have our span record to utilize unused space. A pointer at the end of the first block points to the block containing the remainder of the record, so we can have one record going to another record. We must use span organization when a record is larger than one block. Then we have unspanned. That's when records are not allowed to cross block boundaries. We have file headers, which are just descriptors. We have operations on a file, so we can open the file, we can read the file, find the next, delete the file or modify the file, insert the file, close it, reset it, find all, so locates based on like a condition. We have find in, so this locates in a specific container. We have our find ordered and our recognize. Next we have files of unordered records, and this is basically a heap or a pile where everything is basically unordered and we have to use a linear search to go through it. This is pretty expensive. We can delete, we can leave a space empty or make a marker that we've deleted something, and that holds that. We have our waste or stored space, which recognizes periodic reorganization. And then we have unordered files, and they can be spanned or unspanned, fixed length or variable length, which we talked about earlier. Then we have ways of sorting files. We know we have binary search, which is pretty expensive, but it's less than our linear search, which is the b divided by 2. This is the log base 2. So this one's actually not that bad. Binary search is a lot better than linear search, but we can only do this when it's sorted. If it's unsorted, we have to use linear. So we have these blocks right here, and we can sort by these specific things. We can have a master file, and we can have a unsorted file or an overflow file, where everything's sorted in our master file, and we just throw some things in our overflow file. It's unordered, it's typically smaller, and we can merge them together. Now we have hashing techniques, but we've talked about this in previous classes, so those will be in playlist somewhere on the channel. We also have collisions, so we have most hash functions don't guarantee that distinct values will hash to direct addresses. And then we have collisions. We've also talked about this before in other videos, and collisions happen when both, multiple keys are combined into the same hash, and we have a collision. There's multiple ways you can handle this. We can have an external collision, where we handle this externally. We're going to then have overflow of buckets if these buckets that hold this overflow with too much information. And then we have operations of our external hashing. We can delete, modify, and then we have problems with our static hashing. Hashing techniques allow dynamic file expansion, so these are some things that we can do. We're not covering linear hashing, but let's go over extendable hashing. So we have a directory, an array of 2D bucket arrays. There's global depth, and we can locate the depth of something which is stored in a bucket if we specify the number of bits on which the bucket contents are based. So if we look at an example, if it starts with 000, it's going to go into this bucket. 001 goes into the next bucket, and so on and so forth. So if it's like 000, 5555, 6677, whatever have you, or 000, 0110, it's going to go into this first bucket. And same thing, but respectively for the rest of them. We have overflow, and this is what happens, and this is how we can handle it. Our double directory, we have two-phase multi-way merge sort, and this is where part of it is sorted, part of it's unsorted. So that's another way we can handle this. We have two phases that we can look at. The first is read in and sort main memory size pieces of data, and then write each sorted sublist to a disk. Phase 2 is where we merge all the sorted sublists into a single sorted list. And then we have more information on our phase 2 right here. But that's all the information for our disk storage. Next, we're going to look at indexing structures for files.